Alright class, welcome to page 3 of the notes. I'm going to try to keep these videos for this unit a little bit shorter, like under 15 minutes or so, just so, so as not to overwhelm. Since these problems can kind of take a while and get, a bit intricate with all the systems that we're going to be solving. So just to put a pin into page 2, I forgot to mention at the end, but what we saw is that really the form of the forcing term, what I call the right-hand side, f of t, is going to dictate the form of the particular solution of what you choose for xp. And we saw that on page 2. Okay, so getting into page 3, well, we're going to have the same left-hand side of the differential equation, but now f of t, the right-hand side, the forcing term, if you will, is going to be slightly different. It's going to be 3e to the 2t. So first recall that this is the complementary solution right here, xc equals c1 e to the minus t plus c2 e to the minus 9t. And we're going to make a guess as to which of these three is the right form for the particular solution, given that the forcing term, i.e. the right-hand side, is 3e to the 2t. Well, hopefully you see that this is probably the right way to go, right? A e to the 2t. Knowing nothing else about the problem or how I came up with this, I think you can kind of see that, like, if you start doing derivatives of this particular solution, the derivatives will only involve e to the 2t and some other constant, right? And so when we start adding derivatives of e to the 2t together, we're just going to get more e to the 2t's, and so that should add up to the right-hand side. At least that's the idea. So let's actually see how this works. So we're going to take a guess here. Xp equals a e to the 2t, which says that xp prime is 2a e to the 2t, which says that xp double prime equals 4a e to the 2t. Okay. And let's go back up what we need. So I guess I'll just write this right here. Well, what we need is we need 3e to the 2t to equal xp double prime plus 10xp prime plus 9xp. So what we need is 3e to the 2t equals 4a e to the 2t plus 10 times 2a e to the 2t plus 9 times a e to the 2t. Right? And now what we're going to do is we're just going to simplify the right-hand side. So this is 4a e to the 2t plus 20a e to the 2t plus 9a e to the 2t. All of that combines to give 33 a e to the 2t. Right? And so that means that these two things must be equal. And so you'll notice that the e to the 2t's are there. So that says that the 3 has to equal the 33a. And so a couple of minutes ago when I said we're going to be getting systems of equations, this is what I meant, right? Like, from your guess over here, you're going to find all the derivatives that you need, essentially plug it into the differential equation, and now you'll get these coefficients. This is why it's called undetermined coefficients. You're going to get these coefficients that you'll need to solve for. And in this case, there's only one. In other cases, there will be multiple. But we see here a is just 1 over 11. And now what that tells me is that the full-on solution is xc plus xp. And if you come down here, that tells me that x must be, well, c1 e to the minus t plus c2 e to the minus 9t. If you'll remember, this was our xc, right? And now add on xp. In the next video, we'll do page 4. This example is a bit longer, so I'll save it for its own video.